Hello everybody, today we are going to start multiplication of the matrices. So here exercise for 1.4. Question number 1. Which of the following product of matrices is conformable for multiplication? What is the meaning of this statement? Conformable for multiplication. We are not going to multiply these given matrices. We just have to identify whether these given matrices are conformable for multiplication or not. Can we multiply them or not? Just we have to judge this. Can we multiply these matrices or not? So first, what we will have to do here? We'll just have to know the size of the matrices. We just have to know about the order of the matrices. What is the order of the both matrices here? First, we will have to judge here. How many rows this first matrix has? 1, 2. How many columns this has? 1, 2. So it means its order is 2 by 2. Then we'll come towards the second matrix. Minus 2, 3. How many rows this has? 1, 2. How many columns it has? 1. It has only 1 column. Now how we will judge whether we can multiply these matrices or not? This can be judged by the thing. If both these numbers, here the second one and here the first one, they are same, then we can say these matrices are conformable for multiplication. We can multiply them. But what is this and what is this? This is in order we write first the number of rows, then the number of columns. Here the number of columns of the first matrix should be equal to the number of rows of the second matrix. If they both were equal, then we can say that these matrices are conformable for multiplication. Here we have to write that number of columns of first matrix should be equal to the number of rows of the second matrix. This is the rule. If the number of columns of the first matrix are equal to the number of rows of the second matrix, then we can say that these matrices are conformable for multiplication. Yes, they are conformable for multiplication. Mean to say that we can multiply them. Okay, then we'll come towards its part number 3. Part 2 will have to do yourself. With the same rule, you will check the number of columns and the number of rows over there. Part 3 we are going to do. Part 2, two matrices again given over here. We'll have to identify whether we can multiply them or not. So what we have to check again? We have to check the number of rows and the number of columns of the matrix. The first matrix has 1, 2 rows and 1 column. Rows are the horizontal entries of the matrix and column is the vertical entries of the matrix. So here this has 2 rows and 1 column. The second matrix, 1, 2 rows and 1, 2 columns. It's 2 by 2. Here what we'll have to check? The number of columns of the first and the number of rows of the second. This is 1, this is 2. They are not same. It means the number of columns of the first matrix are not equal to the number of rows of the second matrix. So these matrices are not conformable for multiplication. So what we'll have to write over here? Number of columns of first matrix are not equal to the number of rows of the second matrix. So we will write over here, no, they are not conformable for multiplication. conformable for multiplication. So in such a way, if you have to determine whether the given matrices are conformable for multiplication or not, what do you have to do? You just have to check the number of the columns of the first matrix and the number of the rows of the second matrix. If they both are equal, then we can say they are conformable for multiplication. If they are not equal, so it means they are not conformable for multiplication. Let's come towards question number 2. Question number 2, the matrices A and B are given over here. We have to find A, B. Mean if there is no sign between A and B, we are going to multiply them. Now there is the thing how we will multiply the matrices. How we will multiply the matrices. In the previous question, we checked for the compatibility of their multiplication. So compatibility was if the first matrix has the number of columns that are equal to the number of rows of the second matrix. So this has 1, 2 columns and here are the 1, 2 rows. So these matrices can be multiplied. So how we are going to multiply them? A multiplied by B. I just write it over here. A is 3, 0, minus 1, 2. And B is here 6, 5. The rule that you will have to keep in the mind when we are going to multiply the matrices, what is the rule that we will follow? The rule is this, that the rows of the first matrix will be multiplied to the columns of the second matrix. This rule, rows of the first matrix, they are multiplied to the columns of the second matrix. So, first of all, here, first row is 3, 0 and the column is of the second matrix is 6, 5. So 3, 0 will be multiplied by 6, 5. 3 multiplied by 6 plus 0 multiplied by 5. 3 multiplied by 6 plus 0 multiplied by 5. Same like this. This matrix has 2 rows, but here this matrix has only 1 column. So no more column over here. Then we will move towards the second row, that is minus 1, 2. That will be multiplied to the column of the second matrix, 6, 5. Minus 1 multiplied by 6 plus 2 multiplied by 5. Simplify this. Here I will simplify. 3 6 times 18 plus 0 5 times 0. Minus 6 multiplied by minus 1 multiplied by 6 minus 6 plus 2 5 times 10. So what is the resultant matrix over here? 18 plus 0 is 18. Minus 6 plus 10 is 4. So this is the product of these two given matrices A and B. Now we'll come towards its part 2. That is to multiply B by A. In part 2, we will have to do, here the order is very important. AB or BA, they are the different things. Now we are going to find BA. Mean we are going to multiply B to the matrix A. How we will multiply here? The rule is same. But first we'll have to check, can we multiply them or not? We'll have to check the compatibility. First we will write here the matrix B, that is 6, 5. matrix A, that is 3, 0, minus 1 and 2. For the capability of multiplication, we will have to check the number of columns of the first matrix should be equal to the number of rows of the second. Here the number of columns are 1 and here the number of rows are 1, 2. It means they are not equal. So we will write over here BA, mean multiplication of B to A is not possible. Not possible. Why? You will have to write the reason over here. Because the number of columns of first matrix are not equal to the number of rows of the second matrix. So this is the basic rule how we can check the compatibility of two matrices. Okay, now it's time to solve question number 3. Find the product. Product means multiplication. The two matrices given over here in part 1. We are going to multiply them. I have told you about the rule of the multiplication. The rows of the first matrix are multiplied to the columns of the second matrix. This rule I will write over here. We'll have to keep this in your mind. Rows of the first matrix are multiplied to the columns of the second matrix. So, we are going to multiply the row of the first matrix is 1, 2. The column of the second is 4, 0. Both matrices, this has one row, this has one column. So, 1 multiplied by 4 plus 2 multiplied by 0. Because the first entry will be multiplied by first and the second will be multiplied by second entry. Okay then, we will simplify this because this matrix has only one row. So there is no more row over here. We will solve this. 4 1 times 4 plus 2 0 times 0. So 4 plus 0 is 4. This is the product of these two given matrices. Now we'll come towards its part 2. Part 2 is 1, 2. First matrix has one row and the second has one column. The same type of the matrices are here. The same rule we will apply. The rows will be multiplied to the columns of the second. So row is 1, 2 will be multiplied by 5 minus 4. So here this will be 1 multiplied by 5 plus 2 multiplied by minus 4. You can also put the bracket, you can also put here the sign of multiplication. So 5 1 times 5 plus minus minus 4 2 times 8. So 5 minus 8, we will subtract this 3 and the sign will be of greater value minus. This is the product of these given matrices. Okay, the part 3 is the same like the previous two parts. Fourth is also like same. So I am going to do its part 5. Okay guys, part 5. Now we'll have to check how many rows it has. 1, 2, 3. And the second matrix has 2 columns. So first I will multiply the first row to all the columns of the second. Then I will multiply the second row to all the columns of the second. Then I will multiply the third row to all the columns of the second matrix. So just the rows are multiplied to the columns. 1, 2 will be multiplied by the 4, 0. First column 1 multiplied by 4 plus 2 multiplied by 0. This was the first column. Now the same row will be multiplied to the second column. Row is the same, so we will be in the same row, but column is the second. So So this was the first column, there will be gap and then there will be the second column. So now 1 multiplied by 5 plus 2 multiplied by minus 4. 1 multiplied by 5 plus 2 multiplied by minus 4. Okay, now we will have to multiply the second row, minus 3 0 to 4 0 and then to 5 minus 4. Minus 3 0 will be multiplied by 4 0. Minus 3 multiplied by 4 plus 0 multiplied by 0. Minus 3 multiplied by second column 5 plus 0 multiplied by minus 4. Two rows we have multiplied. Now we'll come towards the third row. Here we will also move to the third row. Third row will be multiplied by the first column, then by the second column. 6 minus 1 multiplied by 4 0. 6 multiplied by 4 plus minus 1 multiplied by 0. 6 multiplied by 5 plus minus 1 multiplied by minus 4. Now we are going to simplify this. After the multiplication of these, what we will get over here? Okay, 4 1 times 4. This is 4 plus 2 0 times 0. Minus 3 multiplied by 4 minus 12 plus 0 into 0 is 0. 6 into 4 is 24 plus minus 1 into 0 is 0. Then 5 1 times 5 plus minus 2 4 times 8. Minus 3 into 5 minus 15 plus minus 0 into 4 is 0. 6 5 times 30 minus is plus 4 1 times 4. Now we will simplify this and we will get the product of these two matrices. 4 plus 0, that is equals to 4. 5 minus 8, that is equals to minus 3. Minus 12 into plus 0, minus 12. Minus 15 minus 0, minus 15. 24 minus 0, that is 24. 30 plus 4, that is 34. So this is the product of these two given matrices. So I am going to summarize this, how we can find the product of two matrices. The rows of the first matrix are always multiplied to the columns of the second matrix. Thank you.